who have like attended that original presentation that I did. There's been a few changes. I've got a slightly different slide deck here, which I'll give you a bit more the context for in just a moment. So this one slightly changed the title to Low Carbon Construction, LCA's Material Reuse and Mass Timber. So trying to focus on a few specific things. I'd just like to acknowledge the traditional owners and the custodians on the lands which I'm on, which is the Wurundjeri Woi Wurrung, and pay respects to elders past, present and emerging. So this specific presentation was put together in April. I've just returned from 2 months of annual leave, so I'm a little bit rusty. This is like my second day back. But I organised this presentation right before I left to have a specific conversation with Chris Gilbert, who I think he was one of the directors of Archia Architects, and now he works for the Australian Sustainable Hardwood, which ASH, and they're the largest vertically integrated mass timber producer in Australia, or in Victoria at least. And so I've met him in the past, and we had a coffee the other month, and I'm just trying to pick his brain about the readiness of mass timber, and I guess in my role, trying to push mass timber and getting quantity surveyors that are just doing a like-for-like swap with the volumes of concrete for timber, and how that's blowing budgets out, or estimates out at the beginning, which then reduces the appetite for the project managers or the council as a whole to pursue mass timber realistically. So we had him join. As you can see, the last agenda item was I set this up, and then I handed it over to them, and I had invited Capital Works and sustainability people in Merri-bek, and also there's a circular economy leadership group that I'm in Victoria, and I think there's probably about 20 or 30 councils in that. So we had a bunch of people online. So there was probably about 60 people that attended this chat. And then we had another Chris from Revival Projects, and they do a lot of building decommissioning, and they will take the materials and redesign them back into the space. So that was the flavor of this particular presentation. But I'll talk to the Saxon Street LCA and what's next at Merri-bek, which when I go into the office this week, I'll get even more context of what's next in the 2 months that I've been away. So I quickly run through this because I'm sure you guys are all across what embodied carbon is and LCAs, but really trying to impress on the people, particularly from the Capital Works that are coming to these presentations, the impact and the scale of what we're talking about. So embodied carbon is all of the emissions that are associated with the materials from the extraction out of the ground, as you can see in the top left, transporting those to processing facilities, processing, and then bringing them to site, assembling, and then eventually maintaining and removing them at end of life. And so obviously that all those images represented as a table is the A1 through to D life cycle. And then LCA is just a systematic analysis of the environmental impacts, and for buildings, obviously, generally expressed in the carbon per square meters. And then for a material specific, it would be the EPD. So I always like to run through this one in particular to scare the shit out of people into action. So why are we trying to measure and reduce it? Well, to keep up with population growth, we unfortunately need to build the equivalent of a New York City every month for the next 40 years. So even if we're building them out of leaves and mycelium, it's a lot of volume that that we have to assemble and manage. So that's a building that's approximately 230 billion square meters, or it would be a building the size of Romania over 40 years. So just to put that into perspective. And when we use the embodied carbon baseline that we got from our LCA, that would create over 131 billion tons of carbon and that's excluding infrastructure. That's just for the buildings. And I think that's about like 6 years of total global emissions. So all the emissions in the entire planet, like 5 of those like years is just on the buildings over 30, 40 years. So not insignificant. And then in terms of its contribution to Australia's emissions, embodied carbon is like 16% approximately of the built environment emissions and 10% of our total carbon emissions. And it will challenge organisations and local government, state and national governments to achieve their net zero carbon targets. And I think just like you guys are obviously across it, but I think we are well away to having the operational like side of things, you know, like sorted as the grid decarbonizes, but we need to have now the focus needs to really turn to the materials. And then concrete, we have an addiction to concrete. It's an amazing material. It can do everything we want, but it alone is responsible for 8% of global carbon emissions. To put that in perspective, I think all global aviation is maybe 2% of like emissions worldwide, and I think animal agriculture is responsible for about 13 to 15% of emissions. So just the production of concrete is almost all of the food that we grow. And you can see on the graph on the right, I imagine this has changed. That's from 2018, but you can see the green line is the cement production, which seemed to have plateaued, but the emissions from that had increased. I think probably in the last 5 years with some of the green cements we've seen, I think the emission intensity is probably dropping, although not sure how much of those claims are reliant on purchasing offsets compared to whether they're producing the cement, the clinker, and the final product in a more sustainable way. So Saxon Street was the name of the project before. It's recently been renamed to I think it's Ballam Ballam Place. So it's a community cultural art like precinct in Brunswick. There was traditionally a couple of older buildings on there, and we've retained some of those, but we've built this this large like 5-story gallery and art like workshops in there as well. And so there's one tenant that has the whole site. And it was kind of before my time. I came on board. My role was created 18 months ago. Some smart chicken had already somehow worked onto the planning permit. I don't know how they got it onto the planning permit, but it said that we had to do an LCA of the building. So I came on board, and I have a background in planning and was reading the planning permit and was like, oh, I don't think anyone's actually actioning this like permit condition. So went to the contractor and the like manager of the building team and was like, hey, if they've signed a construction contract that says that they're going to build the building as per the planning permit, which is kind of what the wording was, then they should also be doing the LCA, like on behalf of us as well. So I think we were also able to get them to pay for it. We worked with the ESD consultant and the architect, the project architect, which was Kennedy Nolan, and the ESD consultant was Finding Infinity. And so they're both progressive professional groups in their own right, I'd say. So we were quite fortunate to like work with them. And so we just like wrote a scope up for what the LCA was, which was essentially we wanted to get the embodied carbon impact of the new like 5-story building, which is shown in green on the right hand side, and we wanted to get a comparison against the base case and then the as-built and optimized, which would have more innovation and like timber in it. We wanted to estimate the embodied carbon we save by retaining the other structures on site. So there's the blue one immediately to the north, and then there's this other structure here in pink, which was partially, it was like deconstructed and rebuilt a different way. It's now like an indoor-outdoor space. It's not a closed-in building. We wanted to do that so we could pat ourselves on the back and go back to the project managers that had made that decision and say, hey, look, you did a good thing. You saved X amount of carbon. We wanted to identify the most carbon-intensive materials on site, which we already know are going to be concrete, steel, aluminium, and glass, but we want to get that in a nice list so we can put forward to the project managers. And we wanted to get some recommendations for future projects, not just in the materials, but and I think this is equally as important, but it's about processes within the organization and checks and balances and what policies are we measuring projects against. And there's a whole lot of behavior change and organizational change that I think this project has like raised, and people are slowly starting to realize. So the report itself, including all the spreadsheets that came at the back of the one-click LCA, was hundreds of pages, but we've got these like pretty little graphs that were generated. So this is the baseline, the case of the building. So not the whole precinct, just that the building footprint in the green. This is if we assume that we didn't do any recycled concrete mixes, that we didn't do Durapanel, which we did in some parts, that we had new bricks instead of recycled, etc. So we've got some assumptions there, and then we've got a breakdown of the percentage of the total carbon, and then here we've got a total the total tons of the carbon. So we can see, even going from the baseline, which was like 4,473, to the as-built, we saved approximately 600 tons, which is good, not great, but good. And that was with, we did have some fly ash in the cement. We did have Durapanels in some of the ceilings and the walls. And for those who don't know, Durapanel is just that recycled straw that's kind of pressed into a rigid panel. It's a company that's been around for 60, 70 years. I think there should be more of it used. And then some of the recycled bricks that we had there as well. And then for optimize, you can see we had a much larger drop, almost 1,000 tons. And we've done all the same things, but now we've got some mass timber in there, and a few other things. I will note that because of the details that we had, the timber is almost a like-for-like swap, volume for concrete to timber, which we know is probably not the most accurate way to do it. But it would have made the life cycle assessment a lot more expensive to have to you would have to get the architect to actually redesign the building as a timber building, and then measure that. So it would have changed the whole structure of the building, which I think is what we were hearing from Ash, is that a timber building is not just a timber version of a concrete building. It's completely different. The foundations are smaller. You need less volume of the timber to uphold, so you get other benefits and savings. But for the purpose of the LCA, it was a good flag to show, or it was a good comparison. And so we've got the three scenarios here in the green, and then we also had them just get the Australian average for a structure of the same kind. So this was poured in situ, the concrete slab with the concrete pylons, and then it had a metal facade on two sides, and concrete tilt slab on another two sides. So it'll be there for 100 years, but it's very carbon intensive. So we can see just from the baseline, we can see that we did save over 700 tons by retaining those two buildings on site. If I go across here, and that's the total number that we actually assume that we created. And so for comparison, Merri-bek is climate active, so we offset our operational emissions. And last year we offset 7,500 tons to claim the carbon neutrality, which is, I don't want to talk about offsets, but it's good. We pat ourselves on the back. We tell the community we're carbon neutral. But then we've gone and created almost half, like over half of those emissions are just in one of the buildings that we built. And no one knows that and no one talks about that. So this is the purpose of doing this analysis, was to really show people that it's not just operational emissions, you know. And then we kind of get this estimate here that if we did build a timber structure, and the timber, you only get rewarded for timber in one click if you're able to confirm that you were going to recycle that timber. The tool makes assumptions about end of life, and so if you aren't able to confirm that you will be recycling the timber, you could assume that it's going to go to landfill, and then those emissions will eventually get released. So that's why it kind of goes into this negative area, just to represent that that's not a given, you know, that saving. But we could have potentially reduced it by 46% on the baseline if we had aimed for the stars and gone for timber. So some of the key recommendations that came out of that report were obviously to conduct the LCA earlier to inform the design and materials, because probably I came on late and picked up that it was a permit condition. We hadn't done the LCA. Needs to be done in like the concept stage. So like as you're doing almost the start of the design and the and like finalizing the budget, it's really tricky to get that at the right timing. And then the LCA should be able to inform some changes to materials in an ideal world. We've seen to consider alternative like facade structures. So there's too much steel in this like building. Even on the right here, you can see, or if I go back maybe to the so even with as built, we've got the external walls is still making up 45% of the total of the total thing. I can try and get a picture of the building now it's completed, and you'll see it's just all kind of the clip lock on the outside of it. So yeah, we really want to consider mass like timber moving like forward. Luckily, we are about where we have the Coburg Library project, which is we're starting to plan and design a new $35 million, $60 million library. And so all these learnings are getting like funneled into that project, so we can try and get the timber aspect in early. And I think even the quantity surveyor that we're working with, in their line item, I think, you know, the construction budget's like 32 million. We have 3% for ESD, so that's about $1 million for ESD, and they have a line item for timber that's meant to be separate from ESD, which is about $1.5 million to $2 million to make it timber. So they're making assumptions that it's a 6 to 10% like bump in the price. And speaking with Ash, that may not be the case. There's a sweet spot that Ash think that timber is almost cost comparative when you take into account the reduction in assembly like times that they can get a multi-level building up in like a week, as opposed to having to have all the concrete cure for 30 days, etc. So there are some other savings that the QSs aren't really including. And then I think the last one is interesting, is to be skeptical of the material like variations through the project. And if the contractor's coming back to you saying, hey, look, I'm going to save you $100,000, well, should they be coming back to you and saying, I'm going to save you $100,000, I'm going to lose, I'm going to spend, you know, and it's going to have this impact on the carbon baseline. I think that's where we need to go. We go, the budget is X million and X tons of carbon, and then having them justify the cost against that. Because during the project, we had the contractor come back and say, we're going to save you $100,000, and we're going to remove all the Durapanel and we're going to replace it with plasterboard. And the contractor has said to the project manager, it's a like for like replacement. Like The plasterboard's the same as DuraPanel. And then the project manager come and ask me, and I go, well, it's not, because DuraPanel's almost carbon neutral, or it's like a carbon negative product because it's a like waste product. The plasterboard isn't. Even if it's low the carbon, it's still going to be more carbon than DuraPanel, and it has a lower thermal like property, and it has a lower acoustic property. Like, there are repercussions here that project managers just don't know because they're construction project managers. They're not like foremen or architects or, so they're just managing emails and the Gantt charts, and they're being told that it's a like for like from the contractors. And if they don't have someone like me or a strong briefing document or a policy that is helping them make the decisions, they're probably going to take the money, because at the moment, at least I can speak for Merri-bek, you're only getting judged on time and money. So they're the two KPIs that the construction projects have. So that's their Bible in a sense. There was another variation. So luckily, I sent all this email back, and then 3 days later, I see the project manager in the office, and I go, "Oh, where are we at with the DuraPanels?" And he goes, "The DuraPanels are in. We're not going to make the change." And I go, "Oh, that's great. That's great." And he goes, "Your email was too long. I didn't want to respond to it, so I've just gone back and said." So we didn't get the win for the right reason, but they didn't want to read the long email with the comparison against the plasterboard and the DuraPanel, so we keep the DuraPanel. There was another one that came through where they took some of the permeable asphalt or the permeable like pavement, and they were going to swap it for asphalt because it was going to save them $50,000, and that had repercussions not in terms of carbon, but that made it so that the project failed the stormwater requirements that are in the planning scheme. So it was another thing going, you can't trust that the contractor saying it's a like for like swap. They don't understand the repercussions in terms of carbon, in terms of stormwater quality. And so a big learning is that the project managers need to be more skeptical about variations, and they need to liaise with who the expert is inside of the council to give them that advice as quickly as they can. In terms of reducing embodied carbon, this is a slide that I've shown the project managers and people multiple times. Obviously, if we can design around the principles of circular economy, that's where we want to get to. We break that down. It could be build nothing. So can we have more flexible use in another building? Can we reuse another building? Can we build less? Can we refurbish? Can we build clever? Can we use low carbon materials, recycle materials, more local materials, so we lose the transportation? Can we dematerialize, which is what you get when you go to timber anyway? And can we use low carbon concrete? And then the build efficiently is the modular offsite construction and the electrification of construction sites. The modular one is tricky. I'm going off the tack here at the moment, but Merri-bek loves to knock down brick sport pavilions and build modular replacements, and they think that's cheaper and it's quicker. But as I'll show you at the end, I'm trying to make the point, if there's been multiple times when I've gone to a project manager, why did we decide to knock that down, and why didn't we just refurbish that pavilion? And they say, oh, it's cheaper. It's cheaper to knock the whole building down, and to get a thing is cheaper. Now, I was going to ask the project manager to renovate their terrace house, and that their terrace house needed an extra 30 square meters on it, would they knock their entire house down and rebuild a new house? I don't know how the economics stack up when they're spending council's money and we're doing public buildings. It's somehow easier and cheaper to knock buildings down. But if you're dealing with your own money on your own house, it's way cheaper to refurbish and keep 80% of the, there's a mentality there, I think, where it kind of isn't people's money and they just want the quick, easy win at work. And so I've got an issue with the modular offsite construction, but that's something else that we're working through. So just real quick, the two examples here are build clever with low carbon materials, and that's obviously going for mass like timber is a really big one. There's a really good example. So Eric Tweedle's stadium, which is in New South Wales. There might be someone on this meeting who knows more than me, but it's a hybrid concrete and mass like timber. It saved 130 tons of CO2. And it says that the timber comes from a forest that produces so much timber that it would grow back in 8 minutes. I'm not sure how real or fudge those numbers are, but at least you start to connect the dots of using a material that can be replaced, that it can eventually grow back, where concrete, we'd need another event and a couple of 100 million years to turn ourselves into dust. And the building looks great as well. You don't lose anything by increasing the timber. And then this other one, this is a good example. So this is build clever with recycled materials. And so this example here is in Richmond in Victoria, called Sanders Place. It was a warehouse from the 70s or 80s, and it
You've just muted for me. I don't know if anyone else is the same.
Can you hear me?
Yeah, we can now.
Oh, okay. Yeah, can now.
Yeah. Apologies, my headphones just decided to die without any heads up. And so you can see here they've used recycled plywood for internal cladding, and other recycled timber throughout the building, the kitchen, bench tops, the shelves, and all the furniture is secondhand. And you can see some more pictures here. They've even kept the ground slab and just drilled holes penetrated through to get plantings on the underside. And there's they use shade sails at the top to close off. And the ESD consultants that worked on Saxon Street, now this is their office. They consulted on this project and now they work out of this building. So the point I'm trying to make with this one, particularly internally with project managers and the decision makers, is refurbishing doesn't mean that it's ugly or it can't meet our requirements. Anything's possible. I think my personal feeling is that it's a lack of creativity, and probably we default to a handful of building designers, and we give them a narrow scope, which is generally, we want to knock this thing down, as opposed to going out for an expression of interest on a square meterage that we need, and letting the architect and the market kind of tell us whether that's possible or not. I think we're doing too much half-cooked analysis and then telling someone that it's too expensive to refurbish it. That's my 2 cents. So what's next at Merri-bek? You can see this beautiful picture on the right. That's an internal shot for Saxon Street, which is a little bit David Lynch, White Lodge at the end of the season there, but beautiful carpet. So we're continuing to embed and trial recycled materials in our smaller building projects. So Save Board's another good one. It's like a compressed Tetra Pak. We've got that at least on the drawings of a sport pavilion that we're doing at the moment. And then obviously magnesium oxide board, trying to get that in to replace the fibers, the fiber cement. We're writing a sustainable infrastructure policy, so that's kind of talking more to the footpaths and the asphalts and everything else in between the buildings. But we're updating our tech notes now to have a preference and an example specification for recycled content. So at the moment, we default to Vic Roads spec with asphalt, which is good in a sense, where Vic Roads has 20% recycled asphalt, but it's not clear on the tech note, so we're just trying to update those things. But even that, the unruly nature of having to update 300 tech notes across the organisation that are owned and managed by 8 or 9 different teams, even trying to find where the PDFs live inside the cloud and who edits the CAD drawings. Even going to those small details is like prohibitive to why these like changes don't get made. Then we're obviously advocating really strongly for low carbon construction for the Coburg Library, as I mentioned. That's interesting. That's going to go out as a designed contest. So I've seen the draft sustainability requirements that is going to go out in that EOI. So it's telling the contestants that we want a building that sequesters more carbon than it creates, or is low carbon and is climate resilient. So there's lots of keywords and phrases in there, and it'll be interesting to see how that process unfolds. And then the big one, we are also writing a refresh of our zero carbon Merri-bek strategy, and I'm trying to get an action in there about creating an embodied carbon baseline for all of the capital works, so buildings and infrastructure, so we can start to measure that as we go. I'm still trying to figure out what the correct methodology. I think Paul Whelan's done a bit of work at City of Melbourne where I think they were using a carbon per dollar like metric. So it's whether you just make a broad assumption that every dollar creates, X amount of carbon, or if you split it out and say roads create this much, like footpaths create this much, and we think these kinds of buildings create this much. We'll see where we land in that. And I think that's almost it. And I continue to challenge the mindset that recycled or low carbon is ugly and not modern and unable to meet the functional requirements, because it absolutely can. And we need to keeping on with the brick buildings that we have around our municipality, at least, that have been there for 100 years and could last another 200 years, or the modular buildings that we are putting up every now and then, which probably only got about 30 years of life in them, really. And that's it.